Hello, and in this video we'll take a look at A-level physics, specifically for EDEXCEL. We'll take a look at work function, threshold frequency, Einstein's photoelectric equation, the electron volt, and also the photon model in this video. So we need to consider the following specification points. Specification point 93 states that we need to understand the terms threshold frequency and work function and be able to use the equation HF equals phi, which is the work function of the given material, plus 1/2 mv squared max, which is the equation for kinetic energy. Specification point 94 states that we need to be able to use the electron volt to express small energies. Specification 5 also states that we need to understand how the photoelectric effect provides evidence for the particle nature of electromagnetic radiation. So, we need to first recap what the photoelectric effect is, and basically, electromagnetic radiation of a particular frequency, such as ultraviolet light, is shone onto a metal surface, and provided that the photon energy absorbed by the free electron present on the metal surface is greater than or equal to the work function of the material, the bonds holding the electron to the material break, and therefore the electron is emitted as a photoelectron. And this process is known as the photoelectric effect. Now, there's two important terms which we have to take into consideration when talking about the photoelectric effect, and these terms are threshold frequency and work function. So threshold frequency is basically defined as the minimum frequency of light which is required to produce the emission of electrons from a metal surface, and work function is defined as the minimum energy required to remove an electron from a metal surface. Moving on, we need to consider Einstein's photoelectric equation, which is given as HF equals phi, which is the work function of the given material, plus 1/2 mv squared max, which is the equation for kinetic energy. So if we take a look at the following question, it states that the surface of an aluminium plate is illuminated with a monochromatic ultraviolet light with a frequency of 2.0 times 10 to the 15 Hz. The work function for aluminium is 4.7 electron volts. Calculate the energy in electron volts carried by one photon of the ultraviolet light. So for the first part of the question, what we need to do is we need to use the formula H equals the work function divided by the frequency. We need to rearrange that formula to end up with the work function being the subject of it. So we have HF equals phi. H is the value 6.63 times 10 to the minus 34 joules per second. We are already given the frequency in the question, which is 2.0 times 10 to the 15 Hz. We multiply the following quantities together and we end up with 1.326 times 10 to the minus 18 joules. Now, to get from joules to electron volts, we divide the answer that we've just got by 1.6 times 10 to the minus 19, which gives us an answer of 8.3 electron volts. And for part 2 of the question, we need to calculate the maximum kinetic energy of the photoelectron emitted from the aluminium surface. So we need to use HF equals phi plus 1/2 mv squared max. We need to rearrange to make the kinetic energy the subject of the formula. So we end up with HF minus the work function is equal to the kinetic energy. We've already worked out what the work function, what the energy in electron volts is from the previous part, which is 8.3. So we do 8.3 minus the work function of aluminium, which is 4.7, and we end up with an answer of 3.6 electron volts. So what is an electron volt? 1 electron volt is the energy acquired by an electron when it is accelerated through the potential difference of 1 volt. So 1 electron volt equals 1.602 times 10 to the minus 19 joules. Conversely, 1 joule is energy acquired by 1 coulomb of charge when it is accelerated through a potential difference of 1 volt. So basically, how many electron volts are there in 1 joule? So we do 1 divided by 1.602 times 10 to the minus 19, and we end up with an answer of 6.24 times 10 to the 18 electron volts. So that would therefore give us 1 joule equaling 6.24 times 10 to the 18 electron volts. And here we have a series of questions where we have to convert joules to electron volts and electron volts to joules. So from joules to electron volts, we divide the following value by 1.6 times 10 to the minus 19. So we do 2.915 times 10 to the minus 15, and we divide it by 1.602 times 10 to the minus 19. And that gives us an answer of 18196.00499 electron volts. And the same procedure applies for the second one. So we do 3.649 times 10 to the minus 4, and we divide it by 1.602 times 10 to the minus 19, which gives us an answer of 2.27 recurring times 10 to the 15 electron volts. And then to convert from electron volts to joules, we just simply multiply the electron volt value by 1.6 times 10 to the minus 19. So we do 15.78 times 1.602, I should say in this case, that's a typo, times 10 to the minus 19, which gives us an answer of 2.5279 times 10 to the minus 18. And we also do 43.65 electron volts times 1.602 times 10 to the minus 19, which gives us an answer of 6.99 times 10 to the minus 18 joules. Now we need to move on to consider the particle model and also the wave model, and why the wave model did not fully support the photoelectric effect. So before we get onto that, we actually have to consider the conclusions of the photoelectric effect. So the conclusion, or the first conclusion, basically states that no photoelectrons are emitted if radiation has a frequency below the threshold frequency. The second point states that the photoelectrons are emitted with a variety of kinetic energies ranging from 0 to some max value. Now, this value of maximum kinetic energy increases with frequency but is unaffected by intensity. And the third point states that the number of photoelectrons emitted per second is proportional to the intensity of radiation. So the wave model actually did not provide any explanation for the threshold frequency. Basically, it stated that it just expects that the energy of the electron would build up and eventually over time it would be emitted as a photoelectron. And then that contradicts the first conclusion point. And then moving on to have a look at the second point of the wave model, it states that the kinetic energy of the electron depends on the intensity, not the frequency. That also contradicts the second conclusion point, which states that the maximum kinetic energy increases with frequency but is unaffected by intensity. Now, if we take the particle model into consideration, the particle model states that one photon interacts with one electron, and a photon has energy proportional to hf, and an electron is emitted if a photon energy is greater than or equal to the work function, or greater than the energy needed to break the bonds holding the electron to the metal surface. And basically, any photon energy over and beyond the work function of the metal is gained by the electron as kinetic energy. Now, the reason that the particle model actually supports the experimental conclusions for the photoelectric effect is due to the photon energy, which is represented by E equals hf, with f being the frequency of incident radiation that has to be above a certain level to produce the emission of electrons from the metal surface. And this certain level is referred to as the threshold frequency. Now furthermore, the range of kinetic energies is due to some of the electrons being deeper down in the metal and some of those electrons being present on the surface. Those that are deeper down, or the electrons that are deeper into the metal, actually lose more energy when they're trying to leave that metal. And to add to this, the photon model states that the kinetic energy and intensity are independent of each other. So this follows through with conclusion 2 that states that the intensity does not affect the kinetic energy. Thank you all for watching. I hope this video has been clear and made sense on any questions regarding work function, threshold frequency, Einstein's photoelectric equation, the electron volt and also the photon model. Thank you all for watching and goodbye.